Hey guys, Dr. Brown here from Kubo Math, coming to you from Tarlac City, Philippines. And in a previous video, we had used this formula that the derivative of cosecant x was negative cosecant x cotangent x. And some people have said, wow, where'd you get that? Okay, so back to that concept of, well, where did that formula come from? In that truest sense, we're going to take the limit, use the limit formula for a derivative, and we're going to derive that. So I've listed the limit as h approaches 0, and several here. So we'll walk through these. Okay, so let's take the limit as h approaches 0 of cosecant x plus h, you know the formula here, minus cosecant x all over h. Okay, now that limit then, if we change cosecant, let's do something here. The limit is h approaches 0 of 1 over sine x plus h. You know, cosecant is 1 over sine minus 1 over cosecant, 1 over sine x, and all that's over h. Alright, so we need to really get a common denominator here. So let's multiply this by sine x over sine x, and multiply this side sine x plus h over sine x plus h. Alright, so now then we have the limit as h approaches 0 of sine x. Actually, I'm going to move the h in there too. H sine x times sine x plus h. And that, for the numerator, we've got sine x times 1, which is sine x, minus sine x plus h. All right, now I've written sine of x plus h would be sine x times cosine h plus cosine x times sine h. So we can plug that in here. So that's sine x minus all of that. So if I have minus all of this, it would be minus sine x cosine h minus, it's minus that positive, so it's a negative, cosine x sine h, and that's all over h sine x times sine x plus h. I'm just going to leave that x plus h for now. Let's see, now we can factor out a sine x here. So we have the limit as h approaches 0 of sine x times 1 minus cosine h over all this stuff here, which is h sine x plus h minus, I'm going to take and put all this other here, minus cosine x sine h, and I'm going to flip around, if you don't mind, put the h on the other end because I want to get it underneath that sine h. So I have sine x sine x plus h times the h. Okay, now if we go through the limit of this guy is h approaches 0, cosine of 0 is 1. So 1 minus 1 makes that a 0 in the numerator. So that side of this thing just becomes 0. So I'm just going to bring this part down. So I have a minus cosine x sine h over sine x sine x plus h times h. Now then, let's work through our limit on that side of it. Okay, is sine h over h. If you take that limit, and we had this in a previous video, that becomes 1. That's not so obvious, but if you plug that in your calculator, put it in radians, and let h be 1 times 10 to the minus 6, for example. Sine of 1 times 10 to the minus 6 will be 1 times 10 to the minus 6, and that divided by 1 times 10 to the minus 6 is 1. So that becomes 1. As h approaches 0, that becomes just sine x. So what do we have here? We have minus cosine x over sine squared x. So sine x minus, and this all times 1. So if we broke that apart, we have, let's take one of those sine, that's 1 over sine x times cosine x over sine x. Okay, so what is 1 over sine x? Cosecant x. So we have a negative, so negative cosecant x. And what is cosine over sine? Cotangent. So cotangent x. Okay, that, you'll notice, the derivative of cosecant x is negative cosecant x cotangent x, which is exactly what we came up with here. So that, my friend, is how they came up with that derivative. I wish I was the guy that developed that to start with, but I'm not. I'm just trying to learn how to use the tools that are out there. Okay. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Help a kid out. Go buy a book for a kid in a local school. Let's support these children and help them grow their minds so that we can build a better tomorrow, okay? All right, that's all for now, and we'll talk to you next time. Thanks.